we're going to be looking at graphing absolute value functions. Just some things to keep in mind is our general form of the absolute value function. There's these two, or this would be our vertex. Remember, in the second form, you do have to divide by b, or solve that for 0 to find your vertex. Or you can also think of the absolute value as piecewise, breaking it into two different functions. One that would, when you're plugging in a positive x, and one where you're plugging in a negative x. So let's take a look at graphing. And we're going to look at both ways. If you're graphing just using the equation, I'm going to take a look at the turning point, or finding the turning point, which is your vertex. And that's just where the center of your V is going to be. So looking at this example, I can see that my vertex, that's 2, and 0, because I don't have anything over here. So if you're not sure how to do that, you can just take what's in the absolute value bar, set that equal to 0, and solve it. And that gives you your x, and then plug that in to get your y, which you plug it to in there. And then you have to ask yourself, is it symmetric? Now, this is an absolute value. It doesn't have any extra variables except for the variable that's in the absolute value bars. So it is going to be symmetric. So looking at our slope, we're just looking for the number that's in front of x. Well, our slope is 1, and that's going to be on the right side. On the left side, it's going to be opposite of that, negative 1. So we can use this information to graph. We're going to start at 2, 0. On the right side, we're going to go up 1 over 1. And on the left side, we'll go up 1, back 1, because it has a negative. So, and there you go. There you go. Now this works great, unless you have another variable that's outside of the absolute value bar, because then it's not going to be symmetric. So when will this not work? When you have another variable. So when you have a variable outside of the absolute value bar. In that case, you would have to find your vertex and then do some test points before the vertex and after the vertex to see what the function would look like on either side. Now, the other thing you can do is just break it into the piecewise. So you know that there's going to be two possibilities when you're plugging in a positive and when you're plugging in a negative x. So first thing you still have to ask yourself is where's the vertex? So we know that the x is 2 and our y is 0 there, so that's our vertex. That gives you, for the x, that gives you your dividing point for your piecewise. So when x is greater than or equal to 2, our function is the original function because we're putting in a positive number, and we're still going to get a positive answer. And then when it is the opposite, when it's less than 2, and that's when we're putting in a negative x, and that affects what our graph's going to look like. So our function for there is the negative of the function, so it would be a negative x plus 2. So that gives us our two possibilities, x minus 2 when x is greater than or equal to 2, or negative x plus 2 when x is less than 2. So this, I still start at my vertex. Some people would say you could plug in points, so you would plug in a 3 and see if 3 would give you 1, you plug in a 4 and that would give you 2. I also think of just graphing this. If I was to graph that, just using information from algebra, I would start at negative 2, go up 1 over 1, and that gives me my points. Now I know that I don't want to consider these lower points because that's in the other region, but that'll give me my general direction of where I'm going. So that's what the right side looks like. And then for the left side, again, I would just use, you can plug points in. You know, you can plug in a 1, plug in a 1, it's a negative 1 plus 2, which is 1. But I like to just think of how I would graph this if it was graphing it just as a line. I would start at 2 and go down 1 over 1, down 1 over 1. Go up on back, and that gives you the And we can see that those graphs are the same. So let's look at some examples. And we'll do them both ways. So on this one, I know it's going to be symmetric. There's no variables outside the absolute value bar, so either method will work. If I'm doing method 1, which I'll do that one in red, I'm looking for my vertex, so I have to solve that for 0. So my vertex is going to be a -2, and when I put a -2 in, what do I get out for y to get it to? So it's going to be my vertex, -2, 0. Then I think about my slope. My slope is what's in front of that x there, and my slope is saying go up 2 over 1. Up 2 over 1, up 2 over 1. So that's my right slope, and then, positive. And my left slope, I was already thinking about that, is going to be the opposite, which is a -2. So I can go up 2, back 1, up 2, back 1. And there we go. Now method 2 would be, I start the same, I find my vertex, which is going to be at -2, 0. That gives me where I'm going to break my piecewise. I'm going to have x is greater than or equal to -2, and I'm going to have x is less than a -2. Sometimes people want to know why is it equal to. Well, I can get a 0 out, and that's why I can put a -2 in, and that's what we call it. So my piecewise for the greater than a -2 is going to be the original function. And then for less, I remember it's a negative of our function, so it's a -2x minus 2x minus. So graphing this, start at the same place. Now I can either plug points in, which I don't really care to do, or I can do this line. It starts at 4 and has a positive slope. Now, because I'm trying to get back to my vertex, I'll go down 1 and back, down 2 and back 1, down 2 and back 1. That's a positive slope, goes up 2, up 2. There we go. And then for the second one, it would start at -4. So I'm just thinking about if I was graphing this line, and it would go up 2, back 1, up 2, back 1, up 2, back 1. Let's see the other side. Not worried about those points. That was just giving me a starting place. And they're exactly the same thing. Example 2. Again, I don't have an issue with symmetry. It's going to be symmetric. I don't have a variable outside of those absolute value bars. Where's my vertex? Well, plug in for that, set that equals 0, solve that, I get 2. And then if I plug the 2 in, I get 1. Or if you know that that's your vertex. So 2, 1. Now my slope, right slope, left slope. The slope's right there. 1, my left slope. Up 1, 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 back 1. What about doing it in pieces? We're going to break it into pieces. I still have that same 2, 1 for my vertex 2, 1. I'm going to have x minus 2 plus 1. So I can combine those, so that would be x minus 1, x minus 1, when x is greater than or equal to 2. So if I think about that, I've been starting here, graphing the line, up 1 over 1, up 1 over 1, up 1 over 1. And then negative x minus 2 plus 1 gives me my other function. So it's a negative x plus 2 plus 1, which is a negative x plus 3. And x is less than 2. Then you could plug in. I just like to start at 3 and go down 1 over 1. And then we get to number 3. And this is where piecewise is probably more efficient. Is this going to be symmetric? It's not, because I have that variable outside of that absolute value. So method one would be to just do your vertex again. So if I plug in, or I look at where it would center, this would be at 2. But if I plug in a 2, I get 2 for my y. That makes sense. So 2, 2. Going to be my vertex. Now I can't use the slope here because it's not symmetric. It's going to be the same on both sides. So I need to just plug in points. So I'll plug in some points before this vertex. So f of 1. What would the f of 1 be? Well, you plug that in, and you would get 1 plus 1, which is 2. So the f of 1 is 2. And then I'll try another point before there because I'm still not sure what's going on there. I'm going to plug in the 0, and I get 2. So it's looking like it's going this way, that vertex. You're not 100% sure you plug another point through f of -1 just to make sure. And plug that in, and I get 2. Now I've got to look at how it looks, what it's going to look like on the other side of that vertex. So we know numbers bigger than that x, so f of 3. If I plug in that, I get 4. And push through. It's 4. And if I plug in f of 4, I'm getting 6. So it's going to be opposite. Put it here and put it. So that method you could still do, you just have to do some test points, maybe not the most efficient method. If I use my piecewise, I'm going to use that vertex as my separating point, so I know it's going to be when x is greater than or equal to, or x is less than 2. Let me change the colors here, let's do that. So I know this is still going to be the point where I'm starting to do. My function is going to be the positive x minus 2 plus x, which will be 2x minus 2. So if I'm graphing that on a line, I would start at -2, go up to 0, 1, up to 0, 1, up to 0, 1, so on. It gives me that side. Now if I do negative x minus 2 plus x, it's negative x plus 2 plus x. X is canceled, so I'm just left with 2 there. So everything lower than 2 is just going to be this horizontal line. The piecewise is a little bit more efficient than not, because